Okay, hello everyone. Thank you. Welcome to Critic University's Fourth Space, first of all, but thank you for joining us for today's event, the Unreal Game Engine Introduction. Part of the Gamerella workshop series, and we're thrilled to welcome Sarah Raine in for that today. And to help situate you, we are streaming to YouTube live from Fourth Space, and we are located here on unceded Indigenous lands in Chichage, Montreal. Here at Fourth Space, we work with our university community to help mobilize knowledge. We co-create daily activities that examine research questions, projects, things happening across the university. We're running today's event as a live stream Zoom meeting. So those of you joining us there and you're kind of participating along, if you have any comments or questions, if you pop those into the chat, we'll see those. And those of you here in the space, later on, if you have any questions, we might bring a microphone around to you, just so that everyone online can hear that also. Okay, but for more context, happy to pass things over to co-organizer and workshop coordinator of Gamerella, Owen Helm. Owen, over to you.
Fantastic. Hi there. Yes, I'm one of the co-organizers and workshop coordinator here at Gamerella. Super excited. The Game Jam starts tomorrow, and so we're super excited to get this one last workshop in before we start. Some quick information about Gamerella. Gamerella is the world's longest running annual game jam and workshop series that focuses on supporting aspiring and emerging game creators from equity-deserving backgrounds. Dissatisfied with the game spaces and opportunities provided for women in Montreal's game scene, Gina Hara and Charlotte Fisher created Gamerella in 2013. That's over 10 years ago now. Since then, Gamerella has welcomed over 1,100 participants in a low-stress, learner-friendly environment. Gamerella participants have come a long way over the years, founded over a dozen game studios, went to study games, became professional freelancers, and got hired by many AAA studios, and even came back to Gamerella to teach, mentor, and become organizers. That's the case with me. Gamerella was my first game jam. I'm now coming back as a mentor and an organizer. It's really a lovely community. Speaking of our community, Sarah here will be running the workshop. She's also a participant this year and is going to take it away.
Hi. So I'm excited to be here. I'm excited to be part of Gamerella this year. And yeah, I'll be sharing my screen and running you through the basics of Unreal. Just for some context, I'm mostly a game designer and a programmer. I have a lot of experience with Unity, I have some experience with Unreal, so I'll be sharing some of that with you today. Share my screen. Yeah, they're working. Can we see the screen?
Yep.
Okay. So first thing you'll see here when you open Unreal is going to be your project browser. It's going to show your most recent projects. We'll want to go in games. We'll be using one of the templates that come with Unreal to learn at first. You probably want to get started with that. It's a bit hard to build everything from scratch completely. We'll be using the third person template, but feel free to experiment with the others as well later on. Quality preset will go with scalable. Otherwise, Unreal by default will put everything on maximum, and your laptop probably can't handle it. At least mine can't. We'll include the starter content, so we have some assets to play with. And we'll disable ray tracing because we don't need that to get started. Here you input the project location where you want the project to be saved and project name, and you'll go ahead and create it. I've already created it just to save us some time because it can take a while.
We'll be using some preset assets, I think, for this workshop. And if folks are interested in following along at home, on the Gamerella website, gamerella.ca, if you navigate to the workshops tab and click on the Unreal one, there are some links there that have these assets, as well as some links that Sarah recommends for future development after the workshop.
Yeah, there's 3 tutorials specifically. One that kind of covers a bit what I'm going to cover. Just if you want another video that kind of maybe digs into some stuff in a little more detail. There's another one that goes over more specifically blueprints in a more exhaustive way. And there's a shorter one about just kind of UI and stuff, because that's not something I'm going to really touch on very much here. So This is what you're going to be greeted with. Well, not exactly. I'm going to reset it to what you're actually going to be greeted with so that everyone can follow. Here's what your screen is going to look like. So briefly, we have the viewport over here, which is going to be your scene with like everything, all the objects, characters, all of that. Here you'll have your outliner that shows you everything that goes in the scene. And here we'll have the detail panels. What I like to do to have more space is move the detail, the outliner here, just to kind of have a clearer view of what's in here. So briefly, some controls to navigate. You'll want the left click to rotate and go forward, backwards. The right click to look around. You can move with WASD while clicking on the right click to navigate, fly around the map like this. You'll want the mouse wheel to zoom in, zoom out. You can press on the mouse wheel and move around like this to keep the same, move around on the same plane. That's most of what you'll need. There's Q and E to go up and down, but you probably won't really need that much. So that's roughly how you like navigate around. It's very much like playing a video game once you get the hang of it. So here you can see that whenever you grab something in the scene, it gets highlighted here in our hierarchy. I'm just gonna hide some stuff. It gets a bit crowded. So for example, here I grab this cube and it highlights the cube. Or grab another one, highlights another cube. And here we have where our player spawns. So I'll just start by running kind of like the basic scene, just so you get an idea of where you get started with. Here we have a fully rigged third-person character. They can move around, they can jump, and everything has like a basic collisions and stuff. And you'll see these cubes have physics to them. So you can play around a bit. And yeah, so we'll start by kind of just, for example, selecting one of these cubes. You'll see here in the detail panels, it kind of shows you everything you need to know about these cubes. So location, rotation, the scale. If you want to make the cubes bigger, for example, you change the scale to like 2, and here we have like a very big cube now. And you'll see the little like gizmo here, the little arrows. You can grab these to move it around the scene. You can also rotate them and scale them using these gizmos. Here in the top right, you'll have a bunch of interesting options for that. We have the move tool, the rotate tool, and the scaling tool. For example, the rotate tool here gives me this circular gizmo for rotation. The scaling tool gives me these here to scale the object in various directions. Okay, I think it's starting to be a bit too big, but you get the idea. And you can also quickly switch between them using the spacebar. It's a very useful shortcut to know. And if we go back here in the details panel, briefly, here's the mesh, which is the 3D model of the object you're looking at. In this case, it's a cube. If I change it to something else, say like a chair, well, suddenly we have a chair, a big chair, but a chair. This is the material of the object. So I can change it, for example, to like wood. These are the ones that come with the starter pack, but obviously like when you'll be working, you'll be able to create your own materials, import your own materials. So now it's a wooden cube.
It's nice that Unreal comes with a lot of these default materials.
Yeah, it's very good.
Some other game engines don't have.
No, for example, like Unity, when you start, you're thrown to the deep end unless you go like out of your way to like download.
Yeah, I wasn't going to name names, but yes.
Well, I mean, I can because I love Unity. I absolutely love it, but it does. The Unreal is very, very beginner friendly. Like once you start, it gives you a lot to play with.
Yeah, it's out of the box solution.
Yeah, very much so. We have other properties, like for example, the physics. So here we have simulate physics. That's going to be important if you want your object to like, well, have physics. If I remove this here, you'll see this box is going to become like a static object. It won't simulate physics anymore. I can't push it. It doesn't react to gravity. I can also set like the mass of the object, disable gravity. So for example, like the box will just be, no more gravity. So you can play around with these, like it's very fun. For example, if you're making projectiles, you probably, if it's like bullets or whatever, you probably don't want them to be affected by gravity. If it's arrows, maybe you do. Collisions are kind of interesting as well. I'll take a deeper look at them when I dive into the blueprint system. But briefly, so here you can set what kind of collisions presets you want. Here it's a physics actor. So an actor is basically anything that you have on your scene that's like considered an object, so not necessarily part of the terrain, but like a door is an actor, a character is an actor. And to kind of go a bit more into that for going back to collisions. No, I'll finish with collisions first, actually. There's also other important ones like block all dynamic objects that we'll be using to do anything that's going to be an obstacle to the player's movement. There is overlap all dynamic that we're going to be using to do trigger events, again, when we get to the blueprints. But just to show briefly, like if I do overlap all dynamic, I'll be able to just like pass through it. So it does still register collisions. So the object is aware that I'm like passing through it, but it's not going to like block my way, which is going to be useful for us. Okay, so moving on from our big cube. We'll go a bit into, I'll just open up here the player blueprint. So blueprints are essentially what Unreal uses for visual scripting. So with Unreal, like you don't have to code it. If you want to code, it's in C++, which is not necessarily like a super beginner-friendly language, as opposed to Unity that has like, say, like a support for like C#, which is like more approachable. But it's fine because you don't have to like go C++ right off the bat. You can start with their blueprint system, and you can make like whole functional games with like blueprints. Really, the only difference is that like blueprints will take a bit more, will run like a bit slower and whatnot. So if you're making the next, like, say, Assassin's Creed or something, you probably don't want to be using blueprints because that's gonna like get heavy. There's like a lot of objects on screen and stuff. But for like most like games, you'll be like making of like a reasonably smaller scope. You're totally fine working completely in blueprints. We're gonna open up here the player blueprint. In the content drawer here at the bottom right of the screen, you have your content drawer. It shows you kind of like everything that is in your assets folder. So for example, here I have the player, I have all the input stuff. We'll take a deeper look at it in a moment. But and here in the starter content, you have like a bunch of like audio files and like sample blueprints and whatnot. So we're gonna look first at the character. Okay, so here it opens up this window. This is the blueprint interface. So it can be a bit like overwhelming when you see it at first, but like, so we'll break it down. Same thing as with the editor. We have the detail panels with like all the properties you want to be playing with. And to your left here, you'll have a breakdown of what is in the object and a breakdown of all the more like programming components of the object. So like all the variables, the functions and stuff like that. And the middle here, this is where the visual scripting happens. So like you don't need to understand everything that's on screen for like this one specifically. This is not necessarily like where you want to be starting. That's why I started with like the template. Making a controller from scratch is like, not ideal.
Do you think you can show how you got to this screen again?
Yes.
Yeah.
So here from the editor, we go in the content drawer at the bottom left, which shows us all of our game content. So all of our assets, the maps, the materials, everything is in here. You can navigate like your regular Explorer. And in the third person folder, this is where all the things specific to the third person template go. Starter content is where all the things specific to the starter content pack go. We go in blueprints and we have the character controller. We just double left click on it and it opens up this window. All the windows are like very customizable. You can like drag them around if you want to have this, for example, like on another monitor, or if you want to like dock it to one side of the screen and have this on the other side, for example. But we don't need that. We'll just make it into tabs. There you go. Okay, so you don't need to understand like everything that's currently on screen. We'll do something much simpler with blueprints, but roughly speaking, this is where the character, the inputs get like initialized by Unreal. It's not like, there's not much to it. It's very much it's done like this every time. How it works is we have these nodes, the red ones. For example, this one is the begin play event. It's an event that whenever you start in a scene is gonna fire off on like all objects. So all objects in the scene will have this begin play event. So you can hook up anything you want to happen at the beginning. Say if in the case of the character, you want to initialize the inputs. If you're making, for example, like a lever or whatever, maybe you'll want to initialize the state of it. If you have some doors, maybe you want to have them like locked or unlocked based on some conditions.
So this is sort of like, I'm trying to analogize it to programming. This is sort of like a start function or a main function.
Yeah, exactly. This is going to be like your start function. There's also, well, we don't see it here because we don't use it, but there's also going to be an update function that's similar to what Unity has, which will fire off an event at every frame of the game. But we'll get to it like in a bit. So here, when we start play, the first thing it does what's called casting. So when you get an object, you don't necessarily know what type of object you're getting. You'll need to like cast it to a specific type of object. In this case, since we know we're like getting the controller for the player, it's gonna cast it to the type of object, which in case is a player controller, right? This stuff is again like a bit more like murky, but just roughly, we have here all the inputs. So the look input to move the camera around, the move input to move the player around, and the jump input. Jump input is probably the simplest, so we'll go for that. The character controller comes with like a jump and a stop jumping function. So all it does really is we're telling it when this action is triggered, it's gonna jump. And when it's complete, meaning when the jump button is released, it's gonna stop jumping. So very, very simple stuff. But we'll do something even simpler. We'll make a door for the character to go through.
Yeah, this is similar to some like the way that Unity does it in its recent systems, where that maps an action to some sort of function or some sort of game thing that happens within the game. And I think it's a very straightforward way of sort of saying like when this happens, do this, instead of coding it to a specific button or writing a whole function to just check for it.
Exactly, like we can see here in the, if I go back to the editor and I go back to my content jar, we can see in the third person, we have this input folder here. And if you go in the actions, every like action the player can perform, like jumping or dashing or shooting, whatever you'll have in your game, is called an input action. So it's very easy to create those. We'll create an interact action for our door. We right click. It's going to show us this little menu here with like everything you can and might want to create. In our case, we'll want to create here in input. Well, I'll just put this maybe a bit higher. An input action. It's very important when you work to like try to follow a consistent naming convention, because when the project becomes like really, really big and you'll be trying to navigate it, you'll thank yourself for it because you'll actually know what each file does. Otherwise, you're going to end up with like a bunch of things named strangely. It's going to be really hard to find what you need to find. So for example, input action here, the like standard naming convention is IA for input action. So we're going to call it input action IA underscore interact. I'm going to double click on it just to show briefly what it looks like. You won't really need to like mess around too much with that, except maybe here we have a parameter called the value type. In our case, since it's just a button, it can either be on or off. So our value type is a Boolean. Booleans are variables that are either on or off. That's the only like values they can have. But you'll also have stuff like a float, so it can have like a numerical value. From like 0, 0.5, 1, 5, 10, whatever. And you'll have vectors either in 2D or 3D. So like a vector is a combination of values. For example, a position in space is going to be like a vector like X, Y, Z, right? In our case, it's just a Boolean for our interact button. We'll go back to the input. And to add it to our like game inputs, now we created the input. we want to go back in our input folder, and we'll have here what's called an input mapping context. That's kind of like a bit like a representation of like your controller. We have the mappings here, and we can see there's already a mapping for the jump, move, and look action. So we'll be going here on the plus button to add an action mapping. And it's going to let us select from the action mappings that already exist in the project. So here, we can see the interact here, but if you're looking for it, you can just do the search, and you have here interact, you add it. And from that point on, there's like nothing more important to add like for now. You can explore like more. There's like a lot of like options if you like want to dig and understand what everything does, but it's not like necessary to get things working. So we'll go back to our character. For our character, now that we created our interact option, we wanted to have an event just like the ones that Unity already made for us. And it's really simple. You just right click, and you can look up basically any method that you want to add to this visual scripting. In our case, if we look for interact, here we have in input, enhanced action events, IA interact, that's what the input that we made. So this input, we didn't even assign it like any buttons or anything yet. We just created the action. So the engine is aware that this is an action that exists and that the player can perform. But we'll go and actually put an input for it in a bit. We'll just have it here for now, just to show kind of that it exists. And this menu is like contextual, right? You can disable the context sensitiveness, but it's gonna add like a lot of options that you probably don't want to be using. And what that means is that, for example, if I take, say, this value here is an input action, like everything you can grab here and like drag and drop to other stuff. If I drag this, it's gonna, when I release it, it's gonna let me again like put another node, right? And it's context sensitive. So if I drag here the input action value, so it in this case interact, and I drag it, it's only gonna show me options that are relevant to what I'm trying to do. So in that way, like Unreal really tries to like remove some of the bloat and like give you a more focused experience, so you don't get like lost in the sauce of like all the possible options. Yeah, what you'll want to be doing often, like whenever you edit your character, is you'll want to save, so you can like Control S, and you'll also want to compile it, because as long as you haven't compiled it, it won't actually, the changes won't take effect. Even though the blueprint will be like saved, the changes will be saved, the actual like object in the game will not change.
So for blueprints that you create, you have to both save them and compile them before that they'll start running in the game.
Exactly.
Okay, that's good.
You can compile them and not save them, like they will run in the game. But like if you close the engine and like discard it, then like it's not, you're gonna run into like some problems.
Does anything else need to be compiled in the game, or is it just blueprints?
Most things need to be, the actual game in and of itself doesn't need to be compiled, because like, well, I mean, when you build it at the end, it will compile itself.
Right.
But otherwise, whenever you run it, it's gonna like compile everything before running it. But every kind of like subsystem here will need to be compiled before you can run it. So for example, like if you're doing, if you're working with like meshes or something, I'll just kind of like show briefly what that can look like. So here we have like the mesh of the cube. If I double click on it, like yeah, like you do need to kind of save stuff. For example, if I make some modifications here to, there's not like important stuff that you need to know for now, but I'll just show an example. If I look up like the size of this cube, if I change the size, I'll need to re-import the mesh, and it's going to be like re-imported in a different size. So it's not recompiling for everything, because recompiling is specifically like for code, but a lot of like subsystems have their own version of applying the effects of whatever you just did on that screen. So yeah, here for back to our interactions. We're going to be creating a door. So how that works, it's really simple. You can right click like we did earlier, or use here the the add to project button. We're gonna add a class. I'll do it in the content browser. It's gonna be easier because I can set where exactly I want to create it. I'll create in like blueprints here. Okay, we have the
So-
blueprint class.
Any new content that we're going to be adding, we should be adding to starter content in this particular case?
Not necessarily. You can create anywhere. Ideally, you probably don't want to be adding stuff directly in these, because when you're going to be making your own project, you'll want to have like your own kind of like file architecture.
Right.
So here we would create like a folder and call it like blueprints. And this is where we would put all our blueprints. Well, okay. Yeah, if it's letting me do it. We create like a blueprints folder, and we'll also probably want to create like an assets folder for everything that's going to be like audio or art assets. And in our blueprints folder, we'll go right click and we'll create a blueprint here. It's one of the options that is like highlighted because it's something you'll want to be doing very often. Blueprints are essentially kind of like a model of an object. They're the equivalent of a prefabs in Unity if you ever use that. So basically when I create like my door blueprint, I'll be able to drag and drop it anywhere I want in my level. And it's always going to be the same door. So if I go and I modify like the blueprint, if I make the door like red, then all the doors I've placed will become like red. However, if I make modifications on the object already in the scene, that's not going to affect back the blueprint. It's like a one-way connection. So if I place a door and then modify it, only that door will have something unique to it. And that's really important because there's some stuff that we'll want to do. For example, if your door is like linked to a button or something and you set that up in the scene, obviously that button is not relevant outside of like that specific door. So you don't want it to be like reflected back for every door in your game. So blueprints are really like models of objects. Okay, so here, the types of blueprints. We choose here like a parent for the blueprint. It's gonna be like kind of the base of your blueprint. An actor, like I said, is gonna be most things in your scene that the player can like interact with. A pawn is something that can be possessed, meaning the player can like take control of it. So for example, a vehicle would be like a pawn. A character is self-explanatory. A player controller is a more like abstract representation of the player controller. You probably won't be like, going into that like just yet. But for example, this is how you control pawns. You'll need like a player controller to tell the engine, okay, right now we're controlling the character, and now we stop controlling the character and we're controlling this vehicle.
I guess something like that would be useful if you were making, say, I don't know, digital tic-tac-toe, and you don't actually have a character in the scene, but you still need to receive input or something like that. Is that how something like that would work?
Not quite, because if you're doing like, for example, digital tic-tac-toe, you'll probably want, do you mean like in the context of like a game where you do have a character?
I'm imagining a game where you're not actually controlling a little person that's walking
Okay, you're
around.
like very much like a tic-tac-toe. Like
Yeah, something like that.
In that case, like most of the game would be played through like kind of a UI. So that's not
Yeah.
exactly the application case
Okay.
for this. This is very much like an abstraction of like the player character.
Right.
So say, for example, if you play Watch Dogs, and Watch Dogs, you have like this little drone the player can deploy. When you deploy the drone, you're no longer controlling your character, you're controlling the drone. So the drone is a pawn, and the player controller now says the current player is controlling the drone,
Right.
not the player character anymore.
Okay.
So it's very much like when you have situations where you're like kind of changing what is the object that represents the player.
Cool. Thanks.
Yeah, and last kind of these are a bit more complex for now, so we're not going to go into them. And we have the scene component, which is going to be other things that are more like static and that you won't really be interacting with. So for example, maybe if you're making like a really like a pretty contraption that's just meant to be like a visual thing with like maybe collisions or something, then it won't need to be like an actor. For example, if you're making like a brick house or whatever that doesn't have like any interactable components to it, it can just be like a scene component. It doesn't need to be like an actor is something that you can like spawn into the world, like bullets or enemies or objects or anything that you can think of, like crates, anything like that. Scene components really are like part of the scene. You need to place them in as the designer. So we'll be creating an actor in our case. We could make it a scene component, but we'll make it an actor. It's a door. We double click it. We're gonna get the same window as last time. Although you can notice here, I still have the character open. So this isn't like when you open a new blueprint, it doesn't like take over that window. They're all like individual windows that you can switch between in your tab system. And you'll often need to be doing that. For example, if you're like hooking things up between blueprints, you'll be doing like a lot of cross-referencing, a lot of setting something here to set something there. So here in our door, this is the viewport that's showing us what the object looks like. Currently, it doesn't look like anything because we didn't put anything yet. And this is the event graph that we were in earlier with the events, and we'll come back to it in a moment. What we're gonna do is we're gonna go here where we have the components that show us what the object is. Door self is like the abstract object, so it's not. It's very much just like this is the object. It doesn't have anything in and of itself. The scene root is just kind of the position of the object. And so we're going to be adding our stuff. So we're going to go right click. And no, actually, we can just use the add component here. We're going to add component, and it asks us like what we want to add. We can start by just adding, say, like a cube. So here we have now a cube. We can modify like the location of the cube, the rotation of the cube. I showed here earlier using like the gizmos to modify these things, but you can also like set them set exactly what you want here, like in the detail panel. You have you have a slider here, and you can also like directly set the value. If you double click on it, you can tap whatever you want. So if I know I specifically want like a 45-degree rotation, I go here and I type 45, enter, here it is. In our case, since we want a door, we'll go here in the static mesh session. So a mesh is like a 3D object. We'll go on the drop-down menu, and we're gonna look for a door because I know that the starter pack comes with a door. There we go. So we now have a door. We can change, like I said, the materials of it. So here, the white part of the door, maybe we want a nice looking wooden door. So it also includes a wood material like I showed earlier. Yeah, we have an oak door. It's not a very pretty door, but it shows the concept.
Wow, the speed of something like this is just amazing. Somebody who uses Unity so much is like, wow.
Yeah, no, everything is like very, very like easy to like set up and get running. Like even here, like in the base scene, like it's really easy to just go and be like, oh, okay, so I want to make like say an interior, right? So maybe you'll go like grab the floor and make it like a wooden floor. The texture is gonna be all like stretched out for like kind of reasons I don't necessarily like want to get into now, because you would need to like make the texture for it to like work in this kind of context, right? But you could still like assign it like a wooden texture that's going to be very, very stretched out here.
Well, it's useful for rapid prototyping.
It is. It's very useful.
Or a game jam.
Yeah, no, exactly. Like in a game jam, you definitely want to get things working like quick and dirty as fast as possible. Like you don't want to get lost in the minutia of things. But there's definitely like a lot to dig in here if you want to. Going back to our door. So here, for example, see it's showing me the yellow icon telling me I haven't compiled. So if I go and like try to place my door, okay. If I had, well, this is just a model, so it's showing me, but if I made any like programming changes, then that wouldn't be reflected in the door, which we'll get to in a moment. Okay, so we have the viewport here, like I said, and we'll go in the event graph. Okay, so what we'll be doing is I'll set up an overlap volume, like I showed earlier with the collision types that are possible. And when the player is gonna walk close to the door is automatically gonna open. So we'll start one step at a time with just the collision part of it. What we want to be doing here, there's an event that's called the on actor begin overlap. Those are the three default that come with every new blueprint you create. There's the begin play, the actor begin overlap, and the event tick is the one that I told you happens at every frame. So just like for demonstration purposes, if I drag this, you want to avoid using it unless you have like a good reason to use it, because chances are what you want to do probably doesn't need to happen like every frame. So if you want to like run an animation, you probably just want to make it like happen and then like be done with it. Because running operations on like every frame can get like a bit expensive. Not at a level that like you'll really like notice for like a game jam project or anything. But if you're making anything bigger, then like it's gonna start struggling a bit if you overuse it too much.
Especially if you spawn in a bunch of them and they're all doing something on the same frame. And it can be pretty crazy.
So I'll drag here and I'll just to demonstrate a bit what that does. I'll do a, for example, like move. What's something easy that I could show? If I set like the location.
So these are placeholder functions or preset functions that come with Unreal?
Yeah, there's like a lot of them. Like if you look here, there's like, you probably don't want to be like just reading through them. Like generally you'll have like an idea of what you're trying to do.
Yeah.
So like you can either like, look it up. Like Unreal has like a very extensive like documentation, which is again something that has like over Unity in the sense of like Unity sometimes you kind of just like left to fend for yourself, but Unreal like it's very easy to like a quick Google search, find anything you want to do, like how you would go about doing that. So for example, like if I want to like, put the vector together from like different variables, it's really simple. I just look up make vector. And here you go. Like it lets me like create a vector that I can use for something else, for example. Which in this case we'll want to do. I'll go quick here just to really show the concept of what I'm doing, but we're gonna get like the location of the object. I'll drag the object. Yeah, you can drag things here from the components. Here it's a cube, but we should name it to a door because this is our door. And once I have here the door, again, everything's context sensitive. So if I drag this and I, for example, want to get the location of my door, or maybe like, let's say the rotation here is going to be more relevant. So if I get like the rotation of my door, I can do here get world rotation. And it's already going to be like hooked up to the door. So the value that I'm getting out of this is going to be the rotation of my door, the current rotation of my door. For stuff like this, for example, rotation is going to be like a vector. So I'll definitely want to break it down into values that I can actually like use, say if I want to modify it. So you can go and you can right click any pin like this where it makes sense. And you can like split them. So if I split here this vector, now it becomes 3 different values that I can use to do whatever it is that I need to do with them. So yeah, in our case here, let's set the location. Let's set the rotation, sorry. So if we want to set the rotation of the actor, I could grab the current rotation at every frame, and then I drag it here and I'll add to it. So I'll do add. And let's say at every frame I want to add, well, let's not put a crazy amount here because it's going to go bad. Let's put like 5. It's going to be too much, but it's fine. And we're going to break down here the rotation again, like I showed. They can also be reassembled the same way, just like right click here and recombine into one value. The reason why I want to split it here is because I want to modify just like one aspect of the rotation. So just like the Z rotation, for example. I don't know if I should go into like kind of a rotation. All right.
You did probably not. I think that it makes sense. There's 3 axes, X, Y, Z, and we're modifying the vertical one in this case Z, because we want the door to spin.
Exactly. Yep. So yeah, I'm gonna hook it up to this. So essentially what this means what this is doing. It's very, very visual. Like when you look at visual scripting like this, you can just kind of trace with your eyes and read what it does. And chances are you're gonna like generally get at a glance what is happening, unless it's something like very like obscure using like a kind of more specific like subsystems. What I'm doing here is I start with the event. Every frame, I'm doing the set actor rotation action. That's gonna modify the Z rotation of the actor. And this new Z rotation, I get it from, we go here, we pick the door current rotation. Yeah, we pick the door current rotation, we get the rotation of the door, and then we pick the Z rotation, we add to it, and we plug it into the new rotation here. I'm just gonna, yeah, I'm setting the world rotation in this case, not the actor rotation. So I'll just change that real quick. One of the dangers of blueprints, though, no matter, like they're very, very useful and very easy to use, but they can get like very cramped if you kind of just like keep adding stuff and not really pay attention to how you organize things. So you really want to keep like things nice and tidy. For example, here, instead of creating like a second door, what I can do is I can just like connect the same door that I've used here, because it's the same object. And maybe I can like place it like here in between. So it's going to be like very like nice and tidy, nice and organized. I can also like double click at a point here on the cable, and I can move it around. So it's very much like cable management at home, but digitally.
That's cool. I didn't know you could do that. That's
yeah, it's very, very nice to like keep things organized, especially like when your functions start to like grow and become complex. You definitely want this to be as readable as possible. So we have this, and we're gonna, again, like I said, hook it up here. And now we're gonna test it out. So we save and we compile. No errors. Now that we have the door here, start. Yeah, we can see the door is rotating by itself.
Look at that. That's great.
Yeah, it's really fun.
Yeah, it's only a couple code blocks and you got it working. That's super
Yeah,
cool.
exactly. Currently, the door has like no collision, so we can go ahead and add that. There's an even simpler way to do that. I just kind of wanted to show a bit like the flow of things, but technically there's also an add world rotation function that kind of skips a bit of what I did. So if I do like add world rotation, and then I select here like for the door, I can like completely omit this part. So we go like right click, and we can like break the link. Break the link, just to kind of show real quick. And it's gonna do like the exact same thing, just in less steps, because we can basically like delete this whole part here. So like, yeah, the nodes can get like really specific. Like chances are if you're trying to do something, there's definitely a way to do it, and like probably not too complex of a way. So all of this here just summed up in like one node that does what I did. So if we launch it here, does the exact same thing. So now we want collisions on that door. I'm just gonna delete this cube. It's distracting. We're gonna go back in our viewport where we can see our door. We're gonna grab our door, and we're gonna double click on our static mesh here, the door. So this door here doesn't come with any collisions. So we're gonna do something really simple. There's a collision menu here in the top left of the screen. And we're gonna add a simplified box collision. When you import your own models, you can like import them with like more complex collisions. But in this case, this door didn't have any. So we'll add a collision to it, and we save. And now when we go here, the door should now have collisions. Let's try that. Yeah, here you go. It's not meant to be used that way, so like it's not always gonna like push us correctly, but the door definitely has collisions. Like I can't pass through it. However, now we want the open like a door, the probably the more proper way, right? So we'll go back here and we'll remove this. We'll use what's called a timeline. So a timeline is like an animation. You animate a certain value over a stretch of time. And we don't want that to happen like every single frame, obviously. We just want it to happen when something specific happens. So what we'll go here and do is we'll create our timeline first and foremost. So we'll look up here, timeline. Add timeline. And we're gonna create, we're gonna call it like open door. Or just open, it's fine. We double click it. And it opens up this animation menu here. We're gonna move it right here. And from here on out, I won't like dig too much into this because it's like, it very much could be like its own workshop. But briefly, you can create here animation tracks. So we'll create one because we want to animate one value. We want to animate the rotation. So we'll do a float track. If we want to animate more complex things, there's like more complex types of animations you could do. So we're going to call it like rotation.
And it's a float track, not a vector track, because you're animating just one part of the rotation.
Exactly. Yeah. I could make it like a vector track and say animate like only like the z component of that vector. But in our case, since we're animating just like one component, it's much easier to just animate.
Do you think you could explain how you got to the timeline again? I think some folks are finding it a little bit fast.
Yes, of course. So here, when I create the timeline, I'll just go ahead. I can like make it again. So I go ahead and create the timeline. Look up timeline in the nodes. I add a timeline. I can call it whatever the name of the animation is. So in this case, open door. And it's very simple. We just double click it. And it opens up the timeline in a new tab. Is that okay? Yeah. So we can create here the float track like we did earlier. The track button is top left. And we're going to call this rotation because that's what the value we're animating is. And from here, it's really simple. We're going to set some nodes, which are basically the points at which our value is modified. So we'll create one key here and like another key. And we're going to set the values of those keys. So this key, I want it to be the neutral position of the door. It's going to happen at the very beginning. I can set the values for the time at which it happens and the value of the key. So the time at which I want to happen is 0 when the animation starts. And the value is going to be 0 as well, because the neutral rotation of the door is going to be at 0 degrees.
It's sort of, yeah, the rotation is just fixed, right?
Exactly. Like it starts at like rotation like 0, that's just like the base rotation. And we're going to want it to end at like 90 degrees, right? Because like we want the door to like rotate like this over like a stretch of time. So we set this first one at 0, 0. And the second key here that we created by right-clicking and do an add key. We're going to set it at the end of our animation. We'll put like 10 for the length. Well, no, 3 is fine. Like 3 seconds to open a door, I think is reasonable enough. We're going to set the time to 3. And now see, we don't see our key anymore. But it's fine because it's very easy to adjust the framing of this window. There's buttons here right next to the time and value that let us zoom in or out to fit the horizontal scope of our animation and the vertical scope. So if we click here, it rescales it. So now I can actually see my key again. And I'm going to change the value of the key. I'm going to click on it. And I'm going to put the value at like 90 for like 90 degrees. And again, we can't see our key anymore. So we're going to reframe it vertically. And now we can see it again. We probably don't want the door to like animate like in a like linear way because that's going to like look very like stilted and robotic. We'll want to add a bit of animation curve to this, which we can do like very easily automatically by like right clicking the node and setting it to automatic interpolation. I don't want to like dig too much into this again because this could be like its whole like own workshop. But yeah, essentially it just like tells you what the animation curve is going to look like. So here, if we set it to automatic and we set this one to automatic as well, you can see now it's not a line anymore, it's a curve, meaning it's going to start by opening like a bit slow, accelerate a bit, and then decelerate when it's done. And simple as that, we have like now our animation. We're going to save and we can close it. We're not going to need it for now. But see that track that we created, rotation, now is a value I can actually like use in my editor. So we're going to do something very similar to what we did last time. We're going to have it hooked up to when this animation is happening, we're going to update the rotation. So we're going to set rotation, set actor rotation, or set the rotation of the door specifically. We're going to break down the rotation because we're only interested in modifying the Z. And we're going to drag the rotation here. And that's hooked up. Now, right now, like nothing can trigger this animation. So that's what we're going to work on doing. We're going to leave the animation aside for a moment, and we're going to talk a bit about physics.
Just a reminder, about an hour in.
1 hour in?
Yeah.
We're good. So I'm going to want to create a physics overlap zone. It's going to be like a cube with no like collision that blocks the player. But that does still fire events like I showed earlier. So we add here. I'm going to add a box collision. We're going to go back in our viewport to take a look at it. We're going to call this our interact zone, I guess. We're going to move it around a bit just to so it makes a bit more sense, because right now it's just like cramped at the bottom of the door. We're going to set the location to like this. So basically, we're determining what is the zone in which the door will open when the player gets close enough to it. I'm gonna make it bigger. Too big. There you go. That's a nice area. Which now allows us to use this event here, the actor begin overlap. So we're gonna drag this to play our animation. I'm gonna bring this here to keep it nice and tidy. And we're gonna compile. And we're gonna give it a try. So you can see here the wireframe of the zone. This is not gonna show up when you actually like play the game, but it shows it for us because it's useful information for you to have as a developer, right? When you start, when you get close to it, the door is gonna open. When you leave, nothing happens, but we can kind of add that really, really quick. So just like we have a begin overlap, we also have an event called end overlap. So actor and overlap. And what we want to do is that when you leave the zone, then the door closes back. In the animation here, we have different parameters. We can play the animation, play it from the start, stop it, reverse it. In this case, we want to reverse it. We want to go from the state that it currently is at. We want to play it in reverse. So if the door wasn't completely open, then it's going to close back from the position it's at.
That's so cool.
Yeah, it's very
Oh my
convenient.
God. What a convenient for like a tool. That's cool.
So we compile, we save, and we go back. So like this, the door opens. And then, then when we get away, door closes back. And like I said, it's really going to do it from the moment that the animation is currently at. So if I just go quick and then leave, it's going to close right back. I can also show how to use the interact input that we added earlier to our player. Because let's say maybe we don't want all our doors to be like automatic doors, right? So for that, we're going to go back into our player here. And we want when the interaction happens, basically, so when it's triggered, we want to call a function on the door. So for that, we're gonna go back to our door and we're gonna create the function. Here briefly though, so these are the functions. A function is, I don't want to assume that like everyone has like a programming background, right? So like variables hold a value and functions are things that you do. So for example, like maybe a variable will be how many keys the player has, and a function will be something like open the door using one of the keys, right? So we'll create a function here. There's the little plus buttons to create functions and variables. And the function that we create in the door is going to be called open, to open the door. And then in our event graph, we'll need an event. Basically, an event is something that you connect to another element in the game. So it happens whenever that other element happens. What we want to do here is we'll create a custom event called on door opened. And in our open function, all it does is just gonna call this event. So on door opened. If we were doing what we were doing earlier, we're just like modifying the rotation directly and stuff, we could do it directly inside the function. But the reason we have to do it here outside of the function is because in Unreal, functions are things that happen on the spot. But a timeline is an animation that plays over time. So it in the background, it does need this event tick to make something happen every frame. But the function, once you call it, it's done. So that's why I'm going to call an event. Basically, what happens is I call the function from the player to the door, and then the door notifies itself, hey, I've been opened. And now in the event graph, the door knows what to do with that. It's going to play its animation. So yeah, we call this function on door opened. We can remove here the overlap. We don't need it anymore. Now it's going to open when we actually interact with it. So we're going to.
Yeah. So rather than the trigger happening when you enter the trigger volume, it's just a key or some button or
Exactly.
some interaction. Yeah.
Exactly. So we're going to play. Now, however, we need something to call this open function, and that happens in the player because the player is the one initiating the action. So you'll often want to be thinking when elements of the scene interact with each other, where is the action coming from? For example, like, does it make sense for this code to exist inside of my button, or do I want this code to exist inside of the player? So for example, if you have like a button on the ground that reacts when the player steps on it, the action probably belongs to the button, because the button is the one reacting to the environment with the overlap physics like we saw. But if the action is happening on the player side, say a player interacting with like a lever or a door or something, the action probably will start at the player side of things. There's no like wrong way of doing it. Like we could have also started from the door, maybe like checked, oh, when the player is in the radius, then we listen for the player's input. It just conceptually makes a bit less sense and might get like harder to track in the long run. But there's no like wrong way to do it. It's very much like what makes the most sense to you. So here, when we interact, when it's triggered, we want to call the door. However, currently, we have no way to communicate with that door. The player is not aware that the door even exists. So the player will also need now an overlap box collider. So we'll go in the player in the viewport. So we were in the event graph a moment ago. We go to the viewport to see what the player looks like. And we're going to go on the capsule component of the player. And a child of that is going to be a box collider like earlier. Box collision. We're going to call that interact volume. Just very important to like name your stuff, because it quickly gets messy when things are named cube and box collider and you don't know what they're for.
It's a classic thing whenever I come over to help somebody with the game jam and it's like, okay, what's going on? And they've got cube all the way down. Yeah.
And like, good question. I guess we'll go one by one.
Yeah, not a slight.
So in the interact volume here, again, we're going to size it up appropriately. So like, this is like, there's no science. It's very much like just what makes sense. Like you don't want the player to interact with a door that's like on the other side of the room, right? So you can like gauge. It also comes with like playtesting, right? If you realize that like the player can do like funny things, like open a door from like somewhere they're not supposed to, you probably want to play with what the radius looks like. Now that the player has an box collision, we're gonna call a method here called yeah, we're gonna wanna grab here all the objects that are currently overlapping that bus collider. So earlier we were listening for an event that is fired off whenever the player enters the radius of something. But here we're not interested in that because like you don't want to always like check for everything you're interacting with if it's not like currently relevant to you, right? We'll want to check only when it's relevant to what we're trying to do. Although this is the wrong component.
So this is like rather than the door listening for the player, this is the player saying, I've now hit the door.
Exactly.
Okay. Yeah.
Okay. So the object type we're listening for here, the actor class, we're going to listen specifically for doors because anything else will just not really make sense. So what we want to interact with are doors. This will return all the objects that are currently overlapping, meaning there might be more than just your door. So what that means is we'll want to go through every object just to make sure that we're interacting with the correct thing. So we'll do a loop because this thing returns here like an array of values. We'll want to loop through each value of the array. So a set loop. No, not what I want to do actually. It's like a for each loop. For each loop is just something that does an action like for every element in the array. The array here is our array of actors that we detected. And what we want to do for each of them is we're gonna call, first of all, we don't know that it's a door. Like we as the developers know that it's a door, and this function here will only get us doors, but the engine doesn't know that we're working with a door. So we need to tell it, hey, these objects I'm working with, they're doors. And for that, we're gonna cast like we saw like way earlier with the player. So we'll do cast to door. So now we know that like the object we're getting is a door. If the cast isn't successful, for example, if somehow you ended up with like trying to interact with like a lamp or something, nothing is going to happen. Or maybe you want something to happen, in which case you can use this node cast failed. In our case, we don't care about that. So we'll just call the function open from the door. See, like normally we wouldn't have access to open because it doesn't belong to the player, and the player is only aware of like what is relevant in the context. But here, since we're doing the node from cast to door, we are aware that we're working with a door, so we know that we have access to the door function. Like for example, if I just look up here, like open, we're getting a bunch of opens for like other things, but we're not getting like our door function, right? So I'm gonna drag, open the door. The target of this action, because it doesn't know, and like again, all we're telling it here is after this action, execute this action. But still, like, what do you execute the action on? There's an input here for the target, and the target here is the door that we're doing this on. And that's gonna call the open door. So if we follow the logic here, once we're done with this, I'll do it from the beginning to the end. Oh, what's wrong? Oh, yeah, I didn't tell it with C, for example. That's why you want to compile, because if you don't, there might be things that just kind of don't make sense or are not like connected properly. But they are important here. So what's going on? The type of object is indeterminate. Yeah, it doesn't know what exactly it's casting. So we want the array element we're currently on, because for each loop, like I said, does something on every element of an array. Now the issue is with this. Why is that? The current value of the blah blah is invalid array inputs. I think it just doesn't know what I'm looking for, so I'll just. No, that's not it. I can't read the whole thing. Must have an input wired into them. Try connecting a make array node.
Doesn't like something with the object types.
Yeah, but I'm not sure why. Okay, I'm not sure specifically why it's doing that, so we'll do it another way. There's always another way when something doesn't work. That's the great part of programming. So we'll check for the event that we were looking for earlier, which was the event actor begin overlap. And oh, that's gonna let me showcase variables too, so that's great. And we're gonna just cache in the door, basically. So we're gonna want the begin overlap and end overlap. When we begin overlapping with that object, we're gonna do the same thing we did here. We wanna try casting it to a door. Cast to door. We're casting the other actor that we're interacting with. And in this case, we're hoping it's a door. And we're gonna create a variable to like remember that that door exists. So we're gonna create a door variable. I'm gonna drag the door and we're gonna set the door to the value we're getting from this. Oh yeah, I need to set the variable type. So here it's Boolean by default. What we want is a variable of type door. Yep, we want to change the variable type. It's recompiling, I think did freeze.
So this method, rather than sending an event directly to the door, we're checking that we've hit the door first, setting some variable true, and then we're going to compare that variable later, I assume.
Yeah, exactly. Basically, like whenever we touch a door, we'll remember that like we are currently interacting with that door, that we're currently like near that door. So when we interact, we know that like we can interact with that door.
Right.
Okay, looks like Unreal just froze, so I'll just reboot real quick.
Classic.
That's something that can happen. That's why you want to save often.
Yes.
Hopefully we didn't lose too much. It's letting me close it.
Good old task manager.
Well, that is part of the game jam experience as well. So save often.
Yes. Yeah, I'm trying to imagine how you're going to do this interact thing, and I'm guessing it's you enter and you set the door, get it, and then later on when you press interact, you're checking if that thing is.
If that door exists,
Yeah,
exactly. Yeah, it's fine. I don't know. Let's see if it can restart. Okay. Hopefully we didn't lose our door. Oh, most of it seems to be still there. And what about the character? Oh yeah, we're good. So I'll recreate my door variable of type door. And when I begin overlap, I'm gonna set this door. We're gonna hook it up here. And the other actor, oh, we wanna check first if it is actually a door. So we're gonna cast to door. And only if it is actually a door do we wanna set the door. So we drag here the object that we wanna cast to, and we drag the result of that cast if the cast is successful. Why does it crash here specifically? No, oh.
I think it's trying to open Visual Studio in the background.
Oh, okay. Okay. We're good. It didn't crash. And when we end overlap, meaning we're no longer near the door, we want to reset it to nothing. We don't have any door anymore. Like I said, quick and dirty, because like technically this doesn't actually like hold true in all scenarios. Like what will happen here is if you're next to like two doors and you get near one and like leave the radius of the first door, but you're still in the radius of the second door, it's gonna like completely erase like both doors from memory. But I don't want to get into like too much like nitty gritty like programming things. So you'll really need to like sit down with a piece of paper and write down what it is you're trying to do and what is like the logic of what you're trying to accomplish, and realize, oh, okay, so that means I need to keep all doors in memory, and that means when I'm leaving, I need to check, do I know this door? If so, yes, remove just that door. But like it's not necessary. We're working with one door. It's fine. We're good. So we want to set the door to nothing here where it's not connected to anything. Now that we have the door, we can get rid of this because we know what door specifically we're doing. We want to check if the door is null, that meaning if it has a value. There's multiple ways to do this, but and when we interact with it, we want the door to open. Okay, here we want to check if the object is valid, meaning it exists and it's like a valid object. It's going to be simpler. So we're checking if our door is valid, and if our door is valid, we want to open it. There we go.
Do we need to cast to door if we leave it?
If we leave it?
Yeah, sorry. If you scroll down to the end overlap.
Yeah.
Do we need to cast that to door as well?
Yes. In this case, it would have worked anyway because the door is like the only thing that we really have.
Oh,
like,
true. Yeah, that's correct.
But you do want to cast it to door just to make sure that it is a door. So it would have worked, but what would have happened is that this would have happened with like any object that like you could interact with, which is not what you want most of the time. So here, you would cast it to door, and if it's a door, then you would like reset the door. You would reset the door. There you go. So just to run through it, basically, when you interact, you check if you have a door in memory. And if you do, you open it. Whenever you get near a door, you record that door in memory. And when you leave the vicinity of the door, you reset the door to like nothing. And when we call open here, we're going to go to our door. And we're going to go to the open function. All it does is fire the event on door opened. And then from that event, the door is going to know to play the open animation. Let's see all that in action. So if I get close to the door, it doesn't open on its own anymore. But I didn't set a key to the interact because I said I would come back to that. So let's do that. We go in our content drawer, we go in our inputs, and we go, let's make sure we added our door here. Yep. Or interact, sorry. And we want to add a trigger. No. Sorry. We want to add here an interaction. So we'll go with keyboard, which is really nice here since like the inputs are like abstracted from like the code you're writing. Is that like if later on you decide like, oh, I want to add like gamepad support to my game, it's really easy to go and just like add that, for example, your interact button on the gamepad will be like the top button or something, and you don't need to change anything in the code you've written. So keyboard, we're going to set like the E key as interact. And go. We're going to save. Yeah, I just need to remove the trigger. Yeah. Now when we lunge, when we get close to the door, nothing happens. But if we press E, the door opens. And I still kept the bit about when you get away from the door will shut down. So if I get away, the door closes on its own. Yeah, so that's it for the blueprints. There's like so much more you could like dig into. Like this is really like very much scratching the surface. But I'm just gonna run through like quickly kind of bit other things that
we have about half an hour left.
Half an hour left. Okay, so I'll just like quick fire some things that might be interesting. Oh yeah, for like our door, we probably want like sound effects when the door opens and closes. So in the little asset pack that I made available, there were some sound effects for the door. So if we go here in assets, all you need to do to drag in assets is very, very easy. You open your folder here where your assets are, and you can drag and drop them. It's that simple. So we're also gonna like place in a chair just to show like how to import a model into the engine. Ideally, we'd want them like better organized, but this is not like super important for just the purposes of demonstrating here. Unless you know what you're doing, you probably don't want to like mess with any of the default like import settings. So we're going to import them. Import them. And we're going to import the sound effects as well. There we go. We now have the sound effects for the door open and door close. And it's really, really simple. We go here in door. When the door opens and closes, we will just want to play sound. We have play sound 2D and play sound at location. Play sound 2D means that if you have anything like for a UI that is meant to be like heard the same way regardless of where you are in the scene, then it's called like a 2D sound. But if you have a sound that is like spatialized that exists within your scene, it's a 3D sound. So we'll want to play the sound from a specific location. That way, if for example, the door opens behind you, the player will hear it like differently in their earphones, depending on like the distance and whatnot, than if the door is like very close and right in front of you. So we'll play at location. We want to get the location, obviously, of our door. So we'll drag the door. We can get location. We want the absolute location because if we get the relative position, it's going to give us the location relative to the parent, in which case it's like just the object in of itself.
Also known, I think, as the local rotation. Is that the same thing?
Yeah, same thing. Because the local rotation will affect like how the object is rotated, like relative to the parent. Here in this case, I just did like the world rotation because we're not like going into that. But say for example, if like you were on a ship and the ship was like rotated, right? Then you want the rotation of the door to be like local to the door because the door object is going to be rotated with the ship. But you always want your rotation to happen on the Z axis, like from the door. Like if the door is like this, if it rotates like this, your Z axis becomes like this. This is the relative rotation versus the world rotation that is like still this.
Yeah.
So
rotations can get super duper complex.
Yeah, exactly. But chances are you probably like won't be needing to make like that distinction too often, like if you're just getting started with this.
Yeah.
So we want the location. I'll grab the location of the object. Yeah, I'm gonna get the world location of it. And we can just select the sound effect. So in which case it's just called like door open, open door actually. So open door. We want to do the same thing when you leave. Want to drag like this, play sound, add location. And we're gonna play closed door. It's very much that simple. It's not pretty straightforward. So just to show. I'm not sure if it's sharing my audio. Is it sharing my audio? If I turn on my audio, is it gonna,
I don't know.
am I gonna hear this too? Okay, well, I'm not 100% sure if it's sharing my audio, but there is a sound effect.
You
So-
could maybe, I don't know if you shared the sound when you
Oh,
start
is
the
that
Zoom.
the
You could
different
stop and
option?
restart the screen share, and there's a little button there that's share sound. I think that's
Sure.
probably what.
So if
Could be what that is.
I stop the share and I reshare. Oh, share sound, here it is. So now if I open it, do we hear the sound effect? Yeah, we hear it. Very bad because my PC is struggling, but the sound effect is there. That's great. Yeah, the Unreal only takes WAV files, so no MP3s. That's for sound effects. I could go, oh yeah, to import a model. We dragged and dropped our chair model. Don't have too many windows.
And so this is going to be useful for, say, if you are making a game and you have somebody on your team who's a 3D modeler and they've done something in, say, Blender, which was our last workshop, and they've made it and they've exported all the textures. Yeah, so that the textures that they've created can be replicated in Engine like this.
Yeah, exactly. Like it's very much as simple as like a drag and drop. So we're gonna go drag all our textures. It's importing. And here we go. And now we can drag the chair. So, okay, fun thing, you don't know for sure what like the scale of objects are going to be once you import them. In this case, this chair is like tiny in Unreal. It's like it's there, but it's very, very small. Oh yeah, when you grab an object and you click on F, it like will focus on the object. That's also a useful thing to know. But it's fine. What we're gonna do for the chair is we can actually fix the scale. That's something that happens like very often when you import models. So we'll grab the chair, we'll go on the static mesh like we did earlier to add the collisions, except this time what we're interested in is the scale of the object. So we'll set it to like maybe 20 times like the original size, and we're going to re-import it. Yep. Why did it not let me import? Chat. Oh no, that's for the level of detail. That's not what I want. Yeah, the issue is there's like a lot of options. So you kind of need to know specifically what you're looking for.
Are we able to scale it in the scene?
Oh, we're definitely able to scale it in the scene. It's just nice to be able to directly scale the mesh in and of itself.
Right.
But it's very much just like looking through all these like things, finding the specific setting you're looking for and re-importing it. But it's as simple as like here we have like the chair, we grab it and we can set the scale to 20 here in Engine, and that works just as well. Or not. What's going on with this chair?
It's so tiny.
Is it just that 20 is like not enough? Oh, okay. No, it's just a very tiny chair. It did work.
Smallest chair in the
It's
world.
just the smallest chair in the world. Okay. I forgot what was the value I put when I was like testing this chair. Here you go. This is a massive chair.
Now it's too big.
Okay, so yeah, it did work. You just change the scale and like re-import the object. But here we have a more still big chair, but it's fine. 200 is good. There you go. And yeah, we want to set the rotation to something that makes sense. What? There you go. Oh, hey, here's our chair. We can set a material to our chair, like for example, one of the default ones, say like wood. But what's more interesting here is we do have a material for the chair. The chair has a material. So we're going to double click on the material for the chair. And we're going to drag and drop our textures that we imported. So we drag here, for example, the color.
So this is a new panel?
Yes, it's specifically for textures. So all we did was, well, it's looking for material. So we just double clicked on the material and it opens up this panel. Again, it's a tab. We can move it around, do whatever we need with it. We dragged and drop here our texture. So for example, I'm just going to import the normal map. I'm not going to go too much into like what each of these do, because again, this could be a workshop in and of itself. But just know that like 3D object will use different kinds of maps for different kind of functions. So for example, here, this is just the map for our color. So we're going to drag it in base color. This one is our normal map. So we're going to drag it in the normal. Normal maps will just affect how the object is affected by light. So like how light will illuminate each part of the object. And this one here is the roughness map. So we'll drag and drop it. It's gonna affect how like rugged the texture appears to be. You can get like very granular with this. So if you have like an artist on the team like that does textures, they're gonna have a field day with this. It's a lot of fun to play with.
Yeah, texturing is another thing that can get super duper complex. But yeah, I think like what you said, generally like those three core concepts of, you know, a color, a normal map, and some sort of roughness or metallic, those are like the main building blocks for any sort of material.
So here we have our chair material assigned, and it looks like a very nice chair. We can add the physics to it like we saw earlier. We grab the chair. We want to simulate the physics. We can set the mass to whatever we want. We want to enable gravity. And collisions are set to physics actor. So when we start, if we run into this chair, it's, yeah, I didn't like, it's a very volatile chair, but you can play with the settings to get something that maybe makes more sense for a chair. And I guess briefly I can touch on adding lighting to the scene. Like we see here, the scene is already lit. It uses let me just find it here. By default here, it has a directional light. When you grab it here, you have access to like all the parameters. So if say I was making like a nighttime scene, maybe I'd want to color the light a bit like blue purple-ish, and I'd want to reduce the intensity of the light. So from like 3 lux to like maybe 1, and here we go, nighttime. So I didn't even have to like change the skybox or anything. Well, I mean, there's still like the sun, but kind of looks like the moon if you squint. And for other types of lighting, you can add here in lights. You have directional lights, point lights, spotlights, rectangular lights, and skylights. You'll probably be using like mostly a lot of like point lights. So anything that like emanates from one single point. You have like say a torch, it's light that comes from like a point, like the torch. Spotlight is pretty self-explanatory. Rectangular light is what you're going to be using to maybe like illuminate, like if you have like a room, like an area to illuminate. So just to like show real quick, we do like a point light here in the scene to illuminate our beautiful chair. We can set, since we want something a bit cozy for the nighttime, so we'll go for like a red color, just kind of play a bit with the intensity. You have like a lot of settings again to play with, but all this is like very like self-explanatory. You just want to like kind of read through. When you hover over something, it tells you what exactly that value does. And you can like always like play around a bit with it and kind of try to figure out what it does. Otherwise, like I said, there's very, very extensive documentation for Unreal. I can show briefly what the other lights look like, but
yeah, I talked a little bit about lights in my Blender workshop, and yeah, I was sort of similar where like area lights are like what I use a lot in something like Blender. If you want to sort of give a nice wide sort of light across everything, and the point light is really like you got to have something in mind. Like I want to use a point light for a very specific purpose, whereas an area light is just like I just want light in my scene, right? And obviously a directional light it's the sun.
Yeah, exactly. So for example, here, like I add like a panel and you can see like it very like lights up in like this big like area pretty evenly. So very good if you just want to like light up like, rooms and stuff, like areas of the map. And yeah, the directional light is coming from like whatever direction you set it as. Usually it's coming from the sky, right? So for example, like I'll take this, I'll duplicate the ground. The shortcut for duplicating is Control D. It's very useful. You'll be using it a lot, especially when you're like blocking out what your map will look like. So I'll just do Control D and I'll drag this up here and I'll move it up like this. There you go. And now we can see like a part of the map is obscured. I'll grab my light and put it like maybe in the more obscured part where we need lighting. And with very minimal effort here, we already have kind of something that looks like this could be the setup for like, say, a building. We could like put walls. We'll have our little door here that we need to open.
Burgundy. I think we're making.
Yeah, I was going for cozy, but this is giving like a little scary. But yeah, no, it's really easy in Unreal like to get stuff looking good fast because Unreal like has so many tools right off the bat. And we didn't even go into exploring really what was in the starter content pack. But if you like look, like there's like, ceiling lights that you can very much just like drag and drop, and here you go, like, it's a ceiling lamp. It does what it says on the can. So I really encourage you to like go and like play with these settings, play with what comes in the starter pack, and just explore. Like I said, Unreal is very easy, no, okay, it's not true. It's not easy, but it's very approachable. It's very easy to like get started with learning. I think that's about all I wanted to cover. So we can go on to questions.
Fantastic. Yeah, we'll open the floor up to questions and for online folks and in person. After a little while, or if we're not receiving any questions directly, we'll sort of close down some parts of the stream and allow folks to come up in person to ask one-on-one questions. Yeah, the floor is open for questions. Yeah, I think that there's a lot you could explore with this.
If anybody on Zoom has any questions or comments or anything, excuse me, they're more than welcome to turn on their cameras and microphones and ask that way, or you can pop them into the chat and we could read them out also.
No, like I said before, coming from a Unity background, it's cool how quickly you can get things out of the box and working. Yeah, there's a lot of sort of preset stuff for things that you would commonly want to do, I think, which is cool. It's kind of like a perfect game jam tool, even though Unity is used quite common. I mean, they're both great.
They're both amazing. I guess like my perspective on that is like kind of Unity is great if you're like experienced with it in the sense that like it very much gives you just the bare minimum. So if you know specifically what you want to do, it's like more lightweight. You don't need to like recompile. Doesn't take as long to like load stuff. It's not as like heavy, but you kind of need to know exactly what you want to do and how to do it. While Unreal like will give you like a lot of resources and support, so you're not just like thrown into the deep end. You'll always have like very easy access to like everything you might probably want to do for a game. Unity, sometimes you need to like really go digging for those features, but yeah, they have their advantages.
Exactly. I think we have a question in the chat. Someone's asking, how did you learn Unreal coming from Unity?
Okay. At first, it was very much like looking up like, oh, Unity to Unreal tutorials. But then I quickly realized that like it wasn't like I couldn't find like good shows that like did exactly what I wanted them to do. So it was very much just like kind of taking the knowledge of what I understood like in Unity and kind of trying to transpose that directly, going like from I guess a proactive standpoint, like really opening Unreal and being like, okay, so I want to make this happen. And then thinking about what are the steps? How would I do this in Unity? I want to do a door in Unity. Okay, I know I would be using events or like functions. So I go and Google, okay, how do you do events in Unreal? How do you do functions? So it was very much like a process of like translating the actual components that I was trying to achieve. Right. Because I couldn't find like a guide that just tells you like, this is how you go into Unreal. That would be convenient, but.
Cool. That's awesome. Yeah. Well, I think that let's open the space up for folks in person if they want to come up and ask any questions. Maybe close down the online part. Yeah, progress from there. Reminder for any folks, Gamerella is happening this weekend. We're full up. It's one of our biggest years. And so if we were able to get a seat and you're able to come, fantastic. I'll see you tomorrow. Otherwise, hopefully see you next year. Thank you for watching. And congratulations. Good job, Sarah.
Thank you so much.
Thank you, Sarah. Thank you, Owen. And thank you, everyone here in the space, for joining us, and those of you online as well. Just let you know, we're going to close up the live stream and right now, but this workshop remains available on our YouTube channel, and you should revisit it there and share it. Okay. Have a great evening or weekend.
One more thing.
Yeah,
on
go for
the
it.
website, on the listing for this workshop, there are some links and some YouTube videos that Sarah's provided if you want to keep going forward with your Unreal learning. So recommend to check those out.
Yeah, like I mentioned, it's gonna go over like kind of when I went into more details, especially like the blueprints. So that's fun if you want to explore further some concept we touched on.
Great. Okay. Thank you, everyone.